Today we'll be learning how to make an S-type system. An S-type system is similar to a P-type system. However, instead of the stars orbiting very close to each other, the stars orbit very far apart and thus have different planetary systems. There are times when only one of the stars has a planetary system. However, that doesn't mean that both the stars cannot have a planetary system. Now we'll learn how to make them. First step is to make two stars. The first step is to choose a mass, which is going to be 0.6 and 1.4. And again, like always, Sun is equivalent to 1. Here though, I recommend that keeping the masses toward the lower end. So you will see that why later. So the next step is the luminosity, which is the mass to the power of 4. So the primary star has a mass of 1.1 solar masses, and thus its luminosity is 1.4641 times that of the sun. And my secondary star has a mass of 0.9 solar masses, and its luminosity is 0.6561 times that of the sun. Next is the diameter, given by the mass to the power of 0.74. For my primary star has a diameter of 1.0731, and that of the second star is 0.924995. Next up, calculating the temperature. This is given by the mass of your star raised to the power of 0.505. In my case, the temperature of the more massive star is 1.0493, and that of the other star is 0.9482. Next step is to calculate the star's lifetime, which is given by m to the power of negative 2.5. So the more massive star has a mass of 0.78799, while that of the secondary star is 1.3014. Next step is to calculate the average separation between the stars. Aim for a real high value here if you want your system to be habitable. I'm going with 550 AU. Next step is to calculate the distance from the barycenter. Like last video, this was given by A, the average separation, multiplied by the mass of the less massive star divided by the sum of both massive, which in this case happens to be 245.5 AU. This is the distance from the primary to the barycenter, and the distance from the secondary to the barycenter is 302.5 AU. Next step is to go for the eccentricity, which is how elliptical an orbit is. Like last video, I'll request you to aim for a low value here to ensure habitability. So the eccentricity of my more massive star is 0.4, and that of the less massive is 0.5. Next step is calculating the maximum and minimum separations. The formulas are the same as last video. However, I'm just going to tell them here. The formula for the max separation is E, the maximum separation, is equal to 1 plus lowercase e, all multiplied by r, the distance from that star to the barycenter. And that of the minimum separation is the same thing, except instead of 1 plus e, it's 1 minus e. And like last video, you have to add both the maximums and minimums. Now it's time for the inner and outer boundaries. Now last video, because the stars were so close to each other, we were being able to treat them as if they were just one massive star. However, here, due to the stars being so far away from each other, we cannot do that, and we have to go back to the old ways. So the inner limit of the primary star is 0.11 AU, and the outer limit of that star is 44 AU. And for the secondary, these values are 0.9 AU and 36 AU. Also, one quick note that I forgot, that is for all solar star systems, the inner limit in this case is exactly 400 times smaller than the outer limit. So if you want, you can take the inner limit and multiply it by 400 to get your outer limit. Next step is to calculate the forbidden zone. The formulas are the same, however, in this case, instead we just need the inner boundary, and we need to make sure that they are outside of the outer limits of each star system to ensure that this is an S-type system. Another rule is that the forbidden zones of both the stars should be the same, and this is why I told you to lower the mass, because then the outer limit is much smaller, thus you can have a smaller inner forbidden zone limit. Next step is to calculate the habitable zone, which is given by the inner limit of this is given by the square root of the luminosity of your star multiplied by 0.95, and the outer limit is given by the square root of the luminosity of your star multiplied by 1.37. So the inner limit of the habitable zone of the primary star is 1.1495 AU, and the outer limit is 1.6577 AU, and that of the secondary star inner limit is 0.7695 AU, and the outer limit of that star is 1.1097 AU. Now we'll calculate the frost line, which is given by R. The frost line is equivalent to 4.85 multiplied by the square root of the luminosity of your star. Again, like with the inner and outer boundaries, make sure you don't add the luminosities and instead calculate the luminosities of these stars separately for the habitable zone and the frost line. Now we are done. We are almost done. Now the only thing you need to do is to place your gas giant, habitable world, and then calculate all the other orbits, and then your system will look like this. This is the primary star system here, and this is the secondary star system 550 AU away. Finished.